Okay, the last part of your part B is problem 5 word problem, and I'm putting several of the problems, 4 problems that might be on there, but the ones I'm doing won't have the same values that will be on your test. So I recommend that before you watch this video that you get out your calculator and work these problems, and then to practice substitute values, whether it be degrees, feet, or anything like that. It's the same word problem with just different values depending on what version you get. Okay, so this is basically your number 5 for part B. If you get number 4 and 5, the rest of the test is pretty easy, so you should do well on your unit exam. Okay, so here's the first problem. You need to read this. You have 2 parts on both of these, on your number 5, on whatever version you get. And again, values like this, or here. Is there any others? Here's one, might change on your version. Okay, so the first thing you're always going to do is draw a picture, and the test requires you to draw a picture. You'll get marks off. So read that and try to draw a picture, and then move on to the next slide. Okay, this is how I drew the picture. They're looking for, what are they looking for first? How far apart are the houses? And then they're going to change the 80 degrees. Instead of 80, they want you to do the same thing with 50. So this one's fairly easy. I'm going to use the law of cosines on this, and I noticed that I'm going to let A equal 50, B equals 60, and gamma equal 80. And I'm going to find C, so, which is X in this case. And we're going to get C squared. I'll just write the formula down. A squared plus B squared minus 2AB cos of gamma. And I fill everything in, and this equals 50 squared plus 60 squared minus 52 times 50 times 60 cosine of 80. Sorry, I'm squeezing it in. So basically you get C equals the square root of 6100 minus 6000 cosine of 50, which is approximately 71.12. Alright, so this would be 71.12. How far are the cities? Now in your part B on this, they're just saying, well, if gamma was 50, so you would change this to 50, change this to 50, and then calculate it in the same manner. Change this to 50. Okay, so law of cosine is pretty easy. Okay, your next problem is about an airplane that flies from city A to B, and then he turns through an angle of 20 degrees and heads towards city C. And you have 2 parts. If the distance between the cities is 300, again this might change. How far it is from city B to city A, and what angle should the pilot turn at city C to return to city A. Okay, so I drew a picture. Your picture might be different than mine, but again you need to kind of read through this problem, make sure you get what they're asking. Here's my picture. I have, they said that it's from A to C, which is this part, is 300 miles, and A to B is 100 miles, and they gave us turns to an angle of 20 degrees. So this is where it turned, the airplane. Now, if it turns through that, do you know what angle? Because angles, supplementary angles equal 180. This would be 160. Okay? So we have to find the other information. We have to find the angle at C, this one here. And I'm going to use the law of sines. So sine of C over 100 equals sine of 160. Where's 160? Here's your 160 over 300. And C is going to equal sine inverse of, I'm going to cross this up and leave this here. So it's going to be 100 sine of 160 degrees over 300 degrees. Alright, so this is approximately 6.55 degrees, which is right here. Now all the angles of the triangle should add up to 180, so when I subtract these two from 180, I get 13.45. That's angle A. So angle A is 13, so all that equals that. Now, the next part we're going to do is find the distance from city B to C. So we need to find this distance here. I'm going to use law of sines as well. So we're looking for this value. And I'm going to use law of sines again. I'm going to get sine of 13.45. And I called it X. But what should it be? It really should be A, but I'll just call it X. Equals sine of 160 over 300. So X equals 300 sine of 13.45 degrees over sine of 160, which is approximately 204.07 miles. So the distance from B to C, distance from B to C is approximately 204 miles and then some. Okay? So the next problem is about a sailboat. You need to read this again. These values will be different. Alright? And you have two parts. So read through that while I move on. I drew the picture. This is St. Thomas, British West Indies. We are looking for this angle and for C. So, and this was 15 degrees. So this was the course. What the course was off by. Okay, so the first thing I want to do is kind of label everything. I'm going to let A equal 72. So this is my angle alpha here. B equals 200. And this is this side. That's across from beta. And then my gamma is 15 degrees. So the side across from gamma is C. And I'm going to use the law of cosines. So I have C squared equals A squared plus B squared minus 2AB cos of 15 degrees You put this in the calculator. So this is 72 squared plus 200 squared minus 2 times 72 times 200 cos of 15. Alright, so when you put all that in and then take the square root of that, we're going to get 131.8 miles approximately. The sailboat is from the island, so the distance the sailboat is from the island. Again, I highly recommend you use your own calculator. Make sure you're really good at using your calculator with this and getting the values that I got. Okay, the part B is what angle should it turn to correct its course. So basically we have to find beta here, then subtract it from 180, because this is the angle they're looking for right here. This angle here. Okay? So we're going to use cosine of beta. And we're going to use the corollaries we talked about in class. A squared plus c squared minus b squared over 2ac. And after you use the calculator, you're going to get 17,444.76 over 18,979.2. Then you're going to take the inverse of that, so cosine inverse to get your beta of this amount. Again, plug in the values and make sure you get the same thing I did. Alright, and that's approximately 156.8 degrees. So let me go back. This is 156.8. And all I have to do to find this angle is subtract this from 180. So I'm going to take 180 degrees minus 156.8 degrees, and the angle to correct the course is 23.2 degrees. Okay? Just be careful with your calculator and you should do fine. It's not that hard. Alright. And the last problem is about the two cities apart from each other. Okay. And you have to, this is the one we did in class, and I put this one on the board, but I forgot to do this part. So again, you might have different values here. Alright? Alright, so read that and we'll continue on. I drew a picture here. Here's where the error was discovered, and we are looking for this angle here. So the first thing we need to know is that this is 10 minutes. So, and we're talking about hours here. So we need to show that 10 minutes equals 1/6 hour, because you're just dividing this by 60 minutes. Okay? Then we need to know that the distance traveled prior to the error is 420 times 1/6, and that gives you your 70 miles per hour. Okay, so the distance traveled prior to the error is 70 miles per hour, which is this right here. Miles per hour. Okay. Now, to find A, which is this length here, which is the first question, we have to find through what angle should the pilot turn to correct its course. So what we're going to do is find A first and then find beta. Okay? So we're going to take A squared equals 300 squared plus 70 squared minus 2 times 300 times 70 cos of 5 degrees. Use your calculator and take the square root. Can you take the square root of both sides? You get 230 miles, 0.35. 230.35 miles. Alright, so this is 230. This is supposed to be miles, not miles per hour, so just miles. Alright. Now, we're going to find beta, which is here. Oops. Find beta, which is here. And we're going to do that on the other side. 230.35 here. We almost have everything filled out. We're almost done. So to find beta, I'm going to use the law of sines. So I'm using the law of cosines and the law of sines. You could probably use the law of cosines if you wanted, but I'm going to use the law of sines. So to find beta, I'm going to do sine of beta over 70 equals sine of 5 degrees over 230.35. Now, that's why we got this value in the first place, so we could find beta. You cross multiply, and basically you're going to get sine inverse of 70 times 50 times sine to the 5 degrees over 230.35 miles equals 1.5 degrees, which equals your beta. Okay, so that's the answer to part. That's not the answer, that's the part that's beta. Alright, so we have to find the part that's to correct. What we're going to do is take angle C, which is going to equal 180 minus 5 degrees minus 1.5 degrees equals 173.5. So for the correction, that's going to be 180 degrees minus 173.5, which equals 6.5 degrees. And that's your answer to part A. Okay, so this is 6.5 degrees. So I found all my angles, and I found that. Now, the other question was, what new constant speed should be maintained so that no time was lost? Alright, and we're going to assume that the speed would have been constant if no error had occurred. Alright, so the time from city A, so we're talking about the time from city A to city B should be, this is my should be, 300 miles divided by 420 miles. Alright? Which equals 5 over 7 hours. The time from city A to the point of error is 10 minutes, which we already know is 1/6 of an hour. Therefore, the remaining part of the trip must be completed. The remaining part of the trip must be completed in 5/7 minus the error, which equals 23/42 hours. Now, let's go back again and see what they're asking. Okay, what is the rate? So what constant speed? So what we're going to do is use our rate equals rate, let me use a different color. Rate equals distance over time. The distance is 230.35 miles, and our time is 23/42. And you're going to use your calculator, and you're going to get approximately 420.62 miles per hour. Alright? Again, you watch the video. If you didn't get it, you need to watch it again and again, and then try to put in different values and try to replicate the same problem with different values. If you can get 4 and 5 and the rest of the test you know is pretty easy, you should do very well.